Somewhere in a quiet limestone valley in Germany, in the summer of 1856, quarry workers pulled a strange skull from the mud. Heavy-browed, long, older than anything in the Bible's timeline of the world. They assumed it belonged to a diseased man, maybe a Russian soldier, maybe a bear. It took decades before science admitted the truth. This was a different kind of human being entirely. Case closed, or so everyone assumed. Then, more than a century later, someone finally measured the space where its brain once sat, and the number came back wrong. Too big. Bigger, on average, than yours. Bigger than mine. And that single fact has spent decades quietly dismantling one of humanity's favorite stories about itself. Picture the skull in your hands. A solid, bony shelf runs above both eyes, built for a face that pushed forward rather than tucked under like ours does. The back of the head swells outward into a shape anatomists call the occipital bun, with no clear match in modern anatomy. Fill that skull with modeling clay or scan it and calculate the volume, and the average comes out around 1,600 cubic centimeters. Modern humans average roughly 1,350. That's not a rounding error. That's a brain often 10 to 20% larger than the one currently reading this sentence. Stand the two skulls side by side and the asymmetry is almost uncomfortable, as if evolution built the smarter model first and then handed the world to a smaller-brained upstart. Naturally, scientists assumed they had an easy explanation. Bigger bodies need bigger brains just to run them, the same way a larger house needs a larger boiler. Neanderthals were shorter than most modern humans, but far more robust, thick-boned and heavily muscled for the brutal cold of Ice Age Europe. Correct for that extra muscle and bone, researchers reasoned, and the gap should close. Mystery solved. Except it wasn't. Even after every correction for body size, a real gap stubbornly remained. So the question got sharper, not softer. If it isn't just bigger bodies, what was all that extra brain actually doing? The answer, when it came, surprised the researchers who found it. Using CT scans and detailed brain shape reconstructions, scientists expected a bigger brain to simply mean a smarter, more capable mind. It didn't work that way at all. The scans suggested Neanderthals poured an unusually large share of their brain into vision and body control. Plausible given a life spent at high latitudes, hunting in dim winter light where sharper sight meant survival. Researchers at Oxford, including Eilund Pearce and Robin Dunbar, proposed exactly this: more neurons spent seeing the world, fewer spent, perhaps, on something else entirely. And here's where it gets uncomfortable. If more of that oversized brain went toward vision and physical coordination, that left comparatively less packed into the regions linked to complex social networks. The mental bandwidth for tracking dozens of relationships, alliances, and reputations at once. Dunbar's work on primates shows that the size of exactly those regions tracks how large a social group an animal can manage. So the Neanderthal brain wasn't simply our brain, but bigger. It may have been a different instrument altogether, exceptional at reading a frozen landscape and a charging animal, but perhaps less built for running a sprawling, gossiping, alliance-hungry tribe. Bigger, in other words, didn't mean better, it meant different. And that distinction is about to matter more than it sounds, because Neanderthals were never the brutish cartoon they were once drawn as. They buried their dead. At Shanidar Cave in Iraq, they cared for a companion blind in one eye and missing part of an arm, a man who could not have hunted and who nonetheless lived for years, fed and protected by people who chose to keep him alive. They crafted pigments and perforated shells into ornaments. In caves in Spain, they left painted markings that, according to uranium thorium dating published in the journal Science, predate the arrival of modern humans in Europe by thousands of years. They almost certainly had some sophisticated form of language. None of that fits the old textbook image of a knuckle-dragging failure. So why does that image still linger in our heads at all? Because it was built on a mistake. Early reconstructions were drawn from incomplete, sometimes pathological skeletons, including one individual whose stooped spine turned out to be severe arthritis, not species-wide posture. 19th century artists, working from a single sick man's bones, gave an entire species a permanent hunch. Science spent over a century undoing one bad diagnosis, so if they weren't primitive, weren't stupid, and weren't hunched, why aren't they still here? This is where the story stops being about brains at all and becomes something else entirely. For decades, the honest answer was simply, they lost. Outcompeted, pushed to marginal land, starved out by a more adaptable newcomer. But that isn't quite what the evidence says either. In 2010, genome sequencing led by Svante Pääbo, work that would eventually earn him a Nobel Prize in 2022, produced a result that stunned the field. Neanderthals and modern humans had interbred repeatedly for thousands of years. Today, most people with European or Asian ancestry carry somewhere between 1 and 2% Neanderthal DNA in every cell of their body. They did not vanish so much as they were absorbed, their genes still quietly shaping the immune systems and skin of billions of people alive right now. Extinction in this case looks a great deal like merger, which means the real story was never bigger brain versus smaller brain, or even who won. It's a story about what intelligence actually is, never one dial to turn up or down, but a landscape of trade-offs, each species investing its neurons where its world demanded them most. A visual cortex tuned for a twilight forest, a social brain tuned for restless, wandering, endlessly talkative bands of Homo sapiens. Two different bets, placed by evolution in the same cold millennia, on the same continent. And maybe that's the real discovery buried in that 1856 quarry. Not a lesser cousin dwarfed by human progress, but a rival intelligence built along different lines that never truly vanished at all. It's there in the shape of a fingernail, the pattern of a hairline, the way a particular immune gene fires to fight off a virus. So, the next time you look in a mirror, consider this. Some fraction of the mind behind those eyes may still be listening to a much older, much larger one.